Every star in the night sky, no matter how bright or enduring it seems, has a story that ends in a dramatic finale. These celestial giants, born from clouds of gas and dust, don't just fade away quietly. They go out with a bang, literally. When a star dies, it doesn't just vanish. It transforms into one of the most powerful and awe-inspiring events in the universe, a supernova. These cosmic explosions are so immense that they can outshine entire galaxies, and their aftermath shapes the very fabric of the cosmos. But what exactly happens when a star dies? Why are supernovas so important? And what can they teach us about the universe we live in? In this video, we're diving into 10 mind-blowing facts about star death and supernovas, events that not only mark the end of a star's life, but also pave the way for new beginnings. From the creation of elements that make up everything around us to the birth of black holes, these stellar explosions are as mysterious as they are magnificent. So, if you've ever looked up at the stars and wondered about their fate, you're in for a journey that will leave you in awe of the universe's incredible power and beauty. Let's explore the life, death, and legacy of stars together. At the heart of every star lies a cosmic engine, tirelessly burning fuel to keep it shining bright. This engine runs on nuclear fusion, a process where hydrogen atoms in the star's core collide and fuse together, creating helium and releasing enormous amounts of energy. It's this energy that powers the star, allowing it to radiate light and heat across the universe. But just like any engine, a star's fuel supply isn't infinite. Over time, the hydrogen in its core gets used up, and when that happens, the star's fate is sealed. Take our Sun, for example. Right now, it's in the prime of its life, steadily converting hydrogen into helium. But in about 5 billion years, that hydrogen will run out. When it does, the Sun's core will no longer have the fuel it needs to sustain fusion, and its life cycle will begin to unravel. This isn't unique to the Sun, it's the destiny of every star. But here's where things get fascinating. How a star dies depends entirely on its size. Smaller stars, like our Sun, will go through a quieter, more gradual process, while massive stars meet their end in spectacular, explosive fashion. This moment, when a star exhausts its fuel, is the beginning of the end, but it's also the start of something extraordinary. The death of a star isn't just an ending, it's a transformation, a cosmic event that reshapes the universe around it. And as we'll see, the size of the star plays a crucial role in determining just how dramatic that transformation will be. When it comes to the end of a star's life, not all paths are created equal. The fate of a star is determined by one key factor: its mass. Think of it like this: stars are cosmic individuals, each with its own unique destiny. Smaller stars, like red dwarfs, live incredibly long lives, burning their fuel slowly and steadily. These stars are the marathon runners of the universe, lasting for trillions of years. But when their time finally comes, they don't go out with a bang. Instead, they fade away quietly, cooling down and dimming until they become faint, cold remnants known as white dwarfs. It's a peaceful, almost poetic end for these stellar underdogs. On the other end of the spectrum, massive stars are the rock stars of the cosmos, bright, intense, and destined for a dramatic finale. These giants burn through their fuel at an astonishing rate, living fast and dying young. When a massive star exhausts its fuel, it doesn't just fade away. Instead, its core collapses under its own gravity, triggering a cataclysmic explosion known as a supernova. This explosion is so powerful that it can outshine an entire galaxy for weeks, releasing more energy in a single moment than our Sun will produce in its entire lifetime. But even among massive stars, there's variety. Take Betelgeuse, for example, a red supergiant in the constellation Orion. This star is so massive that when it eventually explodes, it will be visible from Earth even during the day. And then there are the ultra-massive stars, which are so colossal that their deaths can lead to the formation of black holes, cosmic voids with gravity so strong that not even light can escape. The diversity in how stars die is a testament to the complexity of the universe. From the quiet fading of red dwarfs to the explosive brilliance of supernovas, each star's end is a reflection of its life. And as we'll see next, these explosive deaths aren't just spectacular to witness, they're also crucial to the very fabric of the cosmos, seeding the universe with the building blocks of life itself. When a massive star reaches the end of its life, it doesn't just fade away, it erupts in one of the most violent and energetic events the universe has to offer. A supernova is a cosmic explosion so powerful that it can outshine an entire galaxy, releasing more energy in a few seconds than our Sun will produce over its entire 10 billion-year lifespan. To put that into perspective, the energy released during a supernova is equivalent to detonating billions of nuclear bombs simultaneously. It's a staggering display of raw power, and it all begins with the collapse of a star's core. As the star exhausts its fuel, the outward pressure generated by nuclear fusion can no longer counteract the immense gravitational force pulling inward. The core collapses in on itself, reaching temperatures and densities so extreme that atoms are crushed together. This collapse triggers a shock wave that rips through the star's outer layers, blasting them into space at incredible speeds. The result is a blinding flash of light and energy that can be seen across vast cosmic distances. But what happens after the explosion? The aftermath of a supernova is just as fascinating as the event itself. The shockwave from the explosion sends shockwaves through the surrounding space, compressing nearby gas and dust clouds. This compression can trigger the formation of new stars, essentially turning the death of one star into the birth of many others. Meanwhile, the remnants of the exploded star, whether it's a neutron star or a black hole, become some of the most exotic objects in the universe. Supernovas aren't just spectacular to witness, they're also cosmic recyclers, scattering heavy elements like iron, gold, and uranium into space. These elements, forged in the heart of the dying star, become the building blocks for new planets, stars, and even life itself. In a way, every atom in your body was once part of a star that met its end in a supernova. So, while a supernova marks the end of a star's life, it's also a beginning, a reminder that even in death, stars play a vital role in shaping the universe. And as we'll see next, these explosive events have left their mark on our own solar system, influencing the very world we call home. One of the most astonishing things about supernovas is their ability to create the very elements that make up our world. Deep within the heart of a dying star, the extreme heat and pressure during a supernova act like a cosmic forge, smashing atoms together to form heavier elements. This process, known as nucleosynthesis, is how elements like gold, silver, and even uranium are born. These elements, which are far too heavy to form in the cores of ordinary stars, are forged in the fiery chaos of a supernova explosion. When the star explodes, it doesn't just vanish, it scatters these newly created elements across the cosmos. Imagine a cosmic firework bursting and spreading its glittering remnants far and wide. Over millions of years, these elements mix with clouds of gas and dust, eventually becoming part of new stars, planets, and even living organisms. Take gold, for example. The gold in your jewelry or the reserves deep within Earth's crust didn't originate here. It was created in the heart of a massive star that exploded billions of years ago, long before our solar system even existed. This process isn't just a one-time event, it's part of a grand cosmic cycle. Supernovas are the universe's way of recycling matter, turning the remnants of dead stars into the building blocks for new ones. Without these explosive events, the universe would lack the diversity of elements necessary for planets, life, and even the technology we use every day. But the story doesn't end there. The elements forged in supernovas don't just sit idly in space, they become part of the next generation of stars and planets. When a new star forms, it pulls in these heavy elements along with the surrounding gas and dust. Over time, these elements can coalesce into planets, moons, and even the ingredients for life. In a very real sense, we are all made of stardust, the remnants of stars that lived and died long before our sun was born. This incredible cycle of creation and destruction is a reminder of how interconnected the universe truly is. Every supernova is not just an end, it's a beginning, a cosmic reset that paves the way for new possibilities. And as we'll see next, these explosive events don't just shape the universe on a grand scale, they've also left their mark on our own solar system, influencing the very world we call home. When a supernova explodes, it doesn't just destroy, it creates. The shock waves from these colossal explosions ripple through space, compressing nearby clouds of gas and dust. This compression is like a cosmic spark, igniting the formation of new stars in regions known as stellar nurseries. These nurseries are bustling hubs of activity, where the raw materials of the universe come together to birth the next generation of stars. Take the Orion Nebula, for example. Located in the constellation Orion, this glowing cloud of gas and dust is one of the most famous stellar nurseries in our galaxy. Within its swirling depths, new stars are being born, their light piercing through the darkness as they ignite. But what many people don't realize is that the Orion Nebula and countless other nurseries like it owe their existence, at least in part, to the shockwaves of ancient supernovas. These explosions act as cosmic catalysts, triggering the collapse of gas clouds and setting the stage for star formation. The process is both beautiful and chaotic. As the shockwave from a supernova slams into a gas cloud, it creates pockets of higher density. Gravity takes over from there, pulling these dense regions together until they become hot and dense enough to ignite nuclear fusion. And just like that, a new star is born. This cycle of destruction and creation is a fundamental part of how the universe evolves, with supernovas playing a starring role. But the story doesn't end with the birth of new stars. After a supernova, the remnants of the exploded star, whether it's a neutron star or a black hole, linger in space, becoming part of the cosmic landscape. These remnants are like cosmic fingerprints, marking the spot where a star once shone brightly before meeting its explosive end. And in some cases, they continue to influence their surroundings, shaping the environment for future generations of stars and planets. Supernovas are more than just spectacular light shows. They're the architects of the universe, shaping the cosmos on a grand scale. From triggering the birth of new stars to seeding the universe with heavy elements, these explosive events are a testament to the interconnectedness of all things. And as we'll see next, the remnants left behind by supernovas are just as fascinating as the explosions themselves, offering a glimpse into the incredible forces at work in the universe. After the blinding flash of a supernova fades, what's left behind is just as fascinating as the explosion itself. The core of the star, now stripped of its outer layers, undergoes a dramatic transformation. Depending on the star's original mass, it can collapse into one of two extraordinary objects, a neutron star or a black hole. These remnants are the cosmic fingerprints of the star's explosive end, and they hold secrets about the universe's most extreme conditions. Let's start with neutron stars. Imagine taking the mass of our sun and squeezing it into a sphere no larger than a city. That's the mind-bending density of a neutron star. These objects are so dense that a single teaspoon of their material would weigh billions of tons on Earth. Neutron stars are born when the core of a massive star collapses, crushing protons and electrons together to form neutrons. The result is an object with a surface so smooth that any imperfections would be smaller than a grain of sand. One of the most famous examples of a neutron star remnant is the Crab Nebula. Located in the constellation Taurus, this glowing cloud of gas and dust is the aftermath of a supernova observed by astronomers in the year 1054. At its heart lies a pulsar, a rapidly spinning neutron star that emits beams of radiation like a cosmic lighthouse. The Crab Nebula is a stunning reminder of how the death of a star can give rise to something equally extraordinary. But not all supernova remnants become neutron stars. For the most massive stars, the core's collapse doesn't stop at forming neutrons. Instead, the gravitational pull becomes so intense that not even light can escape, creating a black hole. These cosmic voids are the ultimate endpoint for stars many times more massive than our Sun. Once formed, a black hole's gravity is so powerful that it warps space and time around it, creating a region where the laws of physics as we know them break down. The remnants left behind by supernovas don't just sit idly in space, they continue to shape their surroundings. Neutron stars, for example, can emit powerful jets of radiation and particles, influencing the gas and dust around them. Black holes, on the other hand, can pull in nearby matter, creating swirling disks of material that glow brightly as they're heated to extreme temperatures. These interactions are a testament to the lasting impact of supernovas, even long after the initial explosion has faded. From the birth of neutron stars to the formation of black holes, the remnants of supernovas are a window into the universe's most extreme environments. They remind us that even in death, stars continue to shape the cosmos in profound and unexpected ways. And as we'll see next, these remnants aren't just isolated phenomena, they play a crucial role in the ongoing story of the universe. The impact of a supernova doesn't stop at the boundaries of its own galaxy. These colossal explosions send shockwaves rippling through space, traveling vast distances and influencing the birth of stars in neighboring galaxies. It's a cosmic domino effect where the death of one star can spark the creation of countless others, even in galaxies far away. This process is a key driver of galactic evolution, shaping the universe over billions of years. Take the Large Magellanic Cloud, for example. This small satellite galaxy of the Milky Way has been a hotspot for astronomers studying supernovas and their aftermath. In one notable case, the shockwave from a supernova explosion was observed compressing nearby gas clouds, triggering the formation of new stars. It's like a cosmic chain reaction. One star's explosive end becomes the catalyst for the birth of new stellar systems. This phenomenon isn't just limited to the Large Magellanic Cloud. Across the universe, supernovas play a crucial role in seeding galaxies with the raw materials needed for star formation. The heavy elements forged in these explosions are scattered into space, mixing with interstellar gas and dust. Over time, these enriched clouds collapse under gravity, igniting the birth of new stars and planetary systems. It's a cycle that has been repeating for billions of years, shaping the galaxies we see today. But the influence of supernovas goes beyond just star formation. These shockwaves can also heat up surrounding gas, preventing it from collapsing too quickly and regulating the pace of star birth. This delicate balance ensures that galaxies don't burn through their star-forming material too quickly, allowing them to evolve gradually over cosmic timescales. The ability of supernovas to trigger star formation in distant galaxies is a testament to their far-reaching impact. These explosions aren't just isolated events, they're part of a larger cosmic network, connecting galaxies and driving the evolution of the universe. And as we'll see next, the historical significance of supernovas goes beyond their physical effects, offering us a window into the past and a deeper understanding of the cosmos. Long before telescopes and modern astronomy, humans looked to the skies and witnessed the sudden, brilliant flashes of supernovas. These events, rare and unpredictable, left an indelible mark on history, often interpreted as messages from the gods or signs of impending change. One of the most famous examples is the supernova of 1054 AD, recorded by Chinese astronomers. This explosion was so bright that it was visible in the daytime for nearly a month, and at night it outshone every star in the sky. Today, we know this event as the birth of the Crab Nebula, a stunning remnant that continues to captivate astronomers. But the supernova of 1054 wasn't the only one to capture humanity's imagination. In 1604, another supernova lit up the skies, observed by astronomers like Johannes Kepler. Known as Kepler's supernova, this event was so significant that it challenged the prevailing belief that the heavens were unchanging. It sparked a revolution in how we understand the universe, proving that the cosmos is dynamic and ever-evolving. These historical supernovas weren't just scientific curiosities, they were cultural milestones. In many societies, they were seen as omens, often linked to significant events like the rise or fall of empires. The sudden appearance of a guest star, as they were often called, could inspire awe, fear, or even hope depending on the context. For example, some Native American tribes interpreted the 1054 supernova as a sign of spiritual transformation, while in Europe it was sometimes viewed as a harbinger of disaster. Fast forward to today, and our understanding of supernovas has been transformed by technology. Telescopes, both on Earth and in space, allow us to observe these explosions in unprecedented detail. We can study the light they emit across the entire electromagnetic spectrum, from radio waves to gamma rays, uncovering secrets about the elements they produce and the shock waves they send rippling through space. Satellites like the Hubble Space Telescope and the Chandra X-ray Observatory have given us breathtaking images of supernova remnants, revealing their intricate structures and the processes at work within them. What's truly remarkable is how these modern tools have deepened our connection to the past. By studying the remnants of historical supernovas, we can piece together the stories of these ancient explosions, linking them to the observations made by our ancestors centuries ago. It's a reminder that the universe has always been a source of wonder, inspiring both fear and curiosity in equal measure. And as we continue to explore the cosmos, we're not just uncovering the secrets of supernovas, we're also rediscovering the shared human experience of looking up at the stars and marveling at their mysteries. The advent of modern telescopes has completely transformed how we see and understand supernovas. Gone are the days when we could only observe these cosmic explosions as fleeting points of light in the night sky. Today, instruments like the Hubble Space Telescope and the Chandra X-ray Observatory allow us to peer into the heart of these stellar explosions, capturing breathtaking images that reveal their intricate details. These telescopes don't just take pretty pictures, they provide a wealth of data that has reshaped our understanding of how stars live and die. Take supernova 1987A, for example. Located in the Large Magellanic Cloud, this supernova was the closest observed in centuries, and it became a goldmine for astronomers. Hubble's images of the explosion's aftermath showed a glowing ring of gas and dust expanding outward like ripples on a cosmic pond. Chandra, on the other hand, captured the X-rays emitted by the supernova's shockwaves, revealing the intense energy released during the explosion. Together, these observations gave us an unprecedented look at the life cycle of a massive star, from its explosive death to the formation of its remnant. But the impact of these telescopes goes beyond just one supernova. Hubble and Chandra have observed dozens of supernova remnants, each offering new insights into the processes that drive these cosmic explosions. For instance, Hubble's images of the Crab Nebula have shown us the intricate filaments of gas and dust left behind by the supernova, while Chandra's X-ray observations have revealed the high-energy particles swirling around its central neutron star. These observations have helped us piece together the story of how supernovas shape the universe, from the creation of heavy elements to the birth of new stars. What's truly remarkable is how these telescopes have deepened our understanding of the universe's evolution. By studying supernovas, we've learned that these explosions are not just isolated events, they're part of a larger cosmic cycle. The heavy elements forged in supernovas are scattered across galaxies, becoming the building blocks for new stars, planets, and even life. The shock waves from these explosions trigger the collapse of gas clouds, sparking the birth of new stellar systems. In a very real sense, supernovas are the engines of cosmic change, driving the evolution of galaxies over billions of years. Modern telescopes have given us a front-row seat to these extraordinary events, allowing us to witness the universe's most dramatic moments in stunning detail. And as we continue to explore the cosmos, we're not just learning about the life and death of stars, we're uncovering the story of how the universe itself evolves, one supernova at a time. Supernovas are more than just spectacular cosmic fireworks, they're the architects of the universe itself. These explosive events have shaped the cosmos in ways that are both profound and far-reaching, leaving an indelible mark on everything from the tiniest atoms to the largest galaxies. Without supernovas, the universe as we know it simply wouldn't exist. One of their most critical roles is in creating the heavy elements that make up the world around us. Elements like carbon, oxygen, iron, and even gold are forged in the intense heat and pressure of a supernova explosion. When the star explodes, it scatters these elements across space, seeding the cosmos with the building blocks for new stars, planets, and even life. Every atom in your body, every piece of metal in your phone, and every breath of air you take can trace its origins back to a star that died in a supernova billions of years ago. But supernovas don't just create elements, they also trigger the birth of new stars. The shock waves from these explosions ripple through space, compressing nearby clouds of gas and dust. This compression can ignite the formation of new stellar systems, turning the death of one star into the birth of many others. It's a cosmic cycle of destruction and creation, with supernovas at its heart. On a larger scale, supernovas play a key role in shaping galaxies. The heavy elements they produce enrich the interstellar medium, the vast clouds of gas and dust that fill the space between stars. Over time, these enriched clouds collapse to form new stars and planets, driving the evolution of galaxies. Without supernovas, galaxies would lack the diversity of elements needed to form complex structures like planets and, ultimately, life. The influence of supernovas extends even further. Their shock waves can heat up surrounding gas, regulating the pace of star formation and ensuring that galaxies don't burn through their star-forming material too quickly. This delicate balance allows galaxies to evolve gradually over billions of years, creating the rich tapestry of stars and planets we see today. In the grand scheme of the universe, supernovas are more than just endings, they're beginnings. They remind us that even in death, stars play a vital role in shaping the cosmos. From the creation of heavy elements to the birth of new stars and galaxies, these explosive events are the driving force behind the universe's evolution. As we look up at the night sky, it's humbling to think that the light we see from distant stars carries the echoes of ancient supernovas. These explosions, so violent and yet so beautiful, are a testament to the universe's incredible power and creativity. They remind us that we are all connected to the stars, not just by the light they emit, but by the very atoms that make up our existence. In the end, supernovas are not just the death of stars, they are the birth of everything. It's easy to think of supernovas as distant, otherworldly event spectacles that happen far beyond our reach. But the truth is, these cosmic explosions are closer to us than we realize. In fact, they're a part of us. The elements that make up our bodies, our planet, and everything around us were forged in the hearts of dying stars. Without supernovas, life as we know it wouldn't exist. Take carbon, for example. This element, which forms the backbone of all organic molecules, is created in the fiery chaos of a supernova. It's the same carbon that makes up the DNA in your cells, the trees outside your window, and even the food you eat. Oxygen, another essential ingredient for life, is also a product of these stellar explosions. Every breath you take is made possible by oxygen atoms that were once part of a star that met its end in a supernova billions of years ago. But the connection goes even deeper. The iron in your blood, the calcium in your bones, and the phosphorus in your DNA. All of these elements were born in the intense heat and pressure of a supernova. When these stars exploded, they scattered their elemental building blocks across the cosmos, eventually finding their way into the gas and dust clouds that formed our solar system. Over billions of years, these elements became part of Earth and ultimately part of us. This incredible link between star death and life on Earth is a reminder of how interconnected the universe truly is. We are quite literally made of stardust. Every atom in your body has a cosmic origin story, one that began in the heart of a star and was set in motion by a supernova. It's a humbling thought, isn't it, that the same forces that destroy stars also create the very ingredients necessary for life. As we look to the future, supernova research continues to unlock new mysteries about the universe and our place within it. Scientists are using advanced telescopes and simulations to study these explosions in greater detail than ever before. By understanding how supernovas create and distribute elements, we can learn more about the origins of planets, the evolution of galaxies, and even the potential for life elsewhere in the cosmos. The story of supernovas is far from over. With each new discovery, we're reminded of the profound connection between the stars above and the life below. These cosmic explosions aren't just distant events, they're the very foundation of our existence, a testament to the universe's incredible ability to create, destroy, and create again. And as we continue to explore the cosmos, we're not just uncovering the secrets of supernovas, we're uncovering the story of ourselves. As we peer into the future of astronomy, the study of supernovas is poised to enter a new era of discovery. With cutting-edge telescopes like the James Webb Space Telescope coming online, we're on the brink of unlocking even more secrets about these cosmic explosions. Imagine having a front-row seat to the universe's most dramatic events, but with a level of detail and clarity we've never had before. That's exactly what these next-generation instruments promise to deliver. The James Webb Space Telescope, often referred to as Webb or JWST, is designed to observe the universe in infrared light. This allows it to see through the dust and gas that often obscure supernova remnants, revealing hidden details about their structure and composition. For example, Webb could help us better understand how shock waves from supernovas interact with surrounding material, or even uncover previously unknown types of supernovas that have eluded detection. But Webb isn't the only tool in the astronomer's arsenal. Ground-based observatories like the Vera-C, Rubin Observatory, set to begin operations in the coming years, will scan the entire sky every few nights, capturing fleeting supernova events as they happen. This constant monitoring could lead to the discovery of rare or unusual supernovas, shedding light on the diverse ways stars can meet their end. One of the most exciting possibilities is the chance to observe supernovas in the early universe. By studying these ancient explosions, we can learn more about how the first stars lived and died, and how they contributed to the formation of galaxies. It's like having a time machine that takes us back billions of years, allowing us to witness the universe's formative moments firsthand. Beyond just observing supernovas, these advanced telescopes will also help us understand the mechanisms behind these explosions in greater detail. For instance, we might finally unravel the mystery of how certain massive stars collapse into neutron stars or black holes, or why some supernovas produce gamma-ray bursts, some of the most energetic events in the cosmos. The importance of studying supernovas goes far beyond satisfying our curiosity. These explosions are cosmic laboratories, offering insights into the fundamental forces and processes that shape the universe. By understanding how stars die, we gain a deeper appreciation for how they live and how their deaths pave the way for new beginnings. As we look ahead, the future of supernova research is brighter than ever. With each new discovery, we're not just learning about the stars, we're uncovering the story of the universe itself, one explosion at a time. And as these powerful telescopes turn their gaze to the skies, who knows what incredible revelations await us. The cosmos is full of surprises, and supernovas are just the beginning. Studying the death of stars isn't just about marveling at cosmic fireworks, it's about unlocking the secrets of the universe itself. Supernovas, those spectacular explosions that mark the end of a star's life, are more than just awe-inspiring events. They're cosmic laboratories offering us a window into the fundamental processes that shape everything from the tiniest atoms to the largest galaxies. By understanding how stars die, we gain insights into how the universe began, how it evolves, and even how life itself came to be. One of the most profound reasons to study supernovas is their role in creating the elements that make up our world. Every atom of gold, every molecule of oxygen, and every speck of iron in your body was forged in the heart of a dying star. Without these explosions, the universe would be a very different place, devoid of the complex chemistry that makes planets, life, and even technology possible. Supernovas are the ultimate recyclers, scattering these essential elements across the cosmos and setting the stage for new stars, planets, and potentially new forms of life. But the significance of supernovas goes beyond just creating elements. These explosions also help us understand the origins of the universe itself. By studying the light and energy emitted by supernovas, scientists can measure distances across vast cosmic scales, helping us map the expansion of the universe and even uncover the mysterious force known as dark energy. It's like using a cosmic ruler to measure the fabric of space-time, giving us clues about how the universe has grown and changed over billions of years. Supernovas also play a critical role in the evolution of galaxies. The shock waves from these explosions trigger the collapse of gas clouds, igniting the birth of new stars and planetary systems. This cycle of destruction and creation is a driving force behind the formation of galaxies, shaping the structures we see in the night sky. Without supernovas, galaxies would lack the diversity of elements and the dynamic processes needed to form complex systems like our own solar system. And then there's the question of life beyond Earth. The elements created in supernovas are the building blocks of planets and potentially life. By studying these explosions, we can better understand the conditions necessary for life to arise elsewhere in the universe. Could supernovas have seeded other worlds with the ingredients for life? Could there be planets out there orbiting distant stars where life has taken root thanks to the remnants of a long-dead star? These are the kinds of questions that drive scientists to study supernovas, and they're questions that remind us of our own cosmic origins. At their core, supernovas are a testament to the beauty and complexity of the universe. They remind us that even in death, stars play a vital role in shaping the cosmos. From the creation of elements to the birth of new stars and galaxies, these explosive events are the engines of cosmic change, driving the evolution of the universe over billions of years. So, the next time you look up at the night sky, take a moment to appreciate the stars not just for their light, but for the incredible journey they've taken. Each one has a story, and each story ends in a way that shapes the universe we call home. Supernovas are more than just the death of stars, they're the birth of everything. And by studying them, we're not just learning about the cosmos, we're learning about ourselves. As we wrap up this journey through the life, death, and legacy of stars, let's take a moment to reflect on the incredible power and beauty of these cosmic events. From the creation of elements to the birth of new worlds, supernovas are a reminder of how interconnected the universe truly is. They show us that even in destruction, there is creation, and even in endings, there are new beginnings. Thank you for joining us on this exploration of star death and supernovas. If you've enjoyed this video, don't forget to like, subscribe, and share your thoughts in the comments below. The universe is full of wonders, and we're just getting started. Until next time, keep looking up. The stars have so much more to show us. As we come to the end of our journey through the life and death of stars, let's take a moment to reflect on the 10 incredible facts we've explored about supernovas and star death. These cosmic events are not just distant spectacles, they're the very heartbeat of the universe, shaping everything from the smallest atoms to the largest galaxies. First, we learned that stars are born from clouds of gas and dust, their lives fueled by nuclear fusion. But when their fuel runs out, their fate is sealed. Smaller stars fade into white dwarfs, while massive stars explode in supernovas, some of the most powerful events in the cosmos. These explosions are so bright they can outshine entire galaxies, scattering heavy elements like iron, gold, and uranium across the universe. We also discovered that supernovas are cosmic recyclers, their shockwaves triggering the birth of new stars and planets. The remnants they leave behind, neutron stars and black holes, are some of the most exotic objects in existence, with gravity so strong it warps space and time. And let's not forget the historical supernovas, like the one in 1054, which inspired awe and wonder in ancient civilizations and continue to captivate us today. But perhaps the most astonishing fact is this: every atom in your body, every piece of metal in your phone, and every breath of air you take was forged in the heart of a dying star. As Carl Sagan famously said, "We are made of star stuff." These words remind us that we are not separate from the cosmos. We are a part of it, connected by the very elements that supernovas created billions of years ago. Supernovas are more than just the end of a star's life, they're a beginning. They remind us that even in destruction there is creation, and even in endings there are new possibilities. They are the architects of the universe, shaping galaxies, seeding planets, and paving the way for life itself. So, the next time you look up at the night sky, remember the incredible journey of the stars above. Their light carries the echoes of ancient supernovas, and their legacy lives on in everything around us. The universe is vast, mysterious, and full of wonders, and supernovas are just one chapter in its endless story. If you've enjoyed this exploration of star death and supernovas, let us know in the comments below. What fact surprised you the most? And don't forget to subscribe for more space content. There's so much more to discover. Until next time, keep looking up. The stars have so much more to show us, and the universe is waiting to be explored.